Great. So, what a great crowd. This is good. So, office hours. Today, we're talking about testing. So, let's start. What questions do you have about testing that can guide our conversation about this today?
That's the same question I'm asking. Difference between integration and unit test.
Got it.
And when integration testing, how to go about checking the states of the different parts. I keep hearing spies and stubs and other words thrown around. Like, what does that mean?
Say more about how to test states of different parts.
So, like, I've heard like integration testing would be like you test where you put information into some part of your program that talks to a query that goes to a database and changes something and passes a result back out. And you should, in a good test, check your database and check that the thing in the middle did the right connection and all that. And how do you put the things in the middle to actually view that and give you test results versus just checking the input and output? How do you check the in-between parts if that's what you're supposed to do? Or
Okay.
is that like going well above and beyond the call of testing?
How to test the in-between parts?
Yeah.
I had a question about clean test states, like using fixtures and then destroying them.
Okay.
I would like to see another library, like using tab protocol. I put in the channel like no tab or tape. I was kind of interested in other frameworks other than multi-child.
Okay. Anything else?
I'm sure Mo will come up.
Yeah.
This is like, but yeah, it's a lot of stuff here.
So, why do we do testing?
Defensive programming.
Say more about that. What is defensive programming?
According to the module, it was programming in a way that while you're developing, I guess it helps guide your approach to creating the code, as well as making it easier to pass around, resume, modify, and extend at a later point because of the way that you can walk through the code and evaluate what all's happening in it. That's my understanding.
Yeah, defensive programming and guiding your approach to creating the code are a little bit different. You know, defensive programming, there's a lot to say about it, but you know, you're coding in such a way that you're writing clean and usable code and eliminating the possibility that, or reducing the possibility that someone else that's using your code might not use it correctly or not understand it or whatever. But I love what you were saying about helping guide your approach to creating the code. Guide it towards what? Say it again. Towards quality. Okay. What else?
Speeds up your development process. Speeds up. So if you're working on a team, if you write your tests first, yeah, did you want me to like say something about
Sure,
it?
yeah.
I actually experienced this. I was building a tic-tac-toe board, and there was like two functions, and I sort of assumed that one function would work, and the other function I was using that function, and I started getting errors, and I found out that the error was coming from the previous function. Like I was not like, testing as I was using the function. So I think if I test for all the possibilities that this function can produce outputs, all the outputs, that will speed up the process because then I don't have to go back and do individual. It'll be like clear where the problem is.
Yeah. Oh, to make it clear where the problem is happening. This is huge. You know, if you write some good unit tests of units, individual discrete units of your code, and then something breaks in one of them, you can know exactly where that is and you can zero in on exactly how to fix it, versus if you didn't have any unit tests and your code, you know, you use a command line interface to access a SQL database, whatever, and all of a sudden it just outputs some cryptic error. You have to start, you know, digging through, okay, well, did it happen in this part? Did it happen in that part? You know, do I need to try a mock database? Do I, all of that stuff. Good, to make it clear where the problem is happening. What else? Mira?
I also heard that testing helps in a way like when we encounter some errors later, so we know where it's coming from, so we don't have to do debugging of the whole code, but just to go to that one place.
So is that what we were just talking about making it clear where the problem is happening? Yeah.
And making code robust.
Robust, okay. And why does testing make your code more robust?
So you check it for all kind of possible errors, invalid inputs, and you still may miss some cases, but check it.
Mm-hmm.
I've seen times where like your code does everything you want it to do and other things. You want to make sure it doesn't do the other things. Like you just want to make sure it does what you want it to, and that like putting in if you put some value that you weren't expecting and you don't get some like crazy other result that then can mess up other code that this might be working with. So I guess like when I think of robust code, it's like this is it. It's gonna do exactly what you said it was gonna do, and only that, to make sure it doesn't mess up other parts of things that it's trying to handle.
Yeah. Yeah, that to me gets at a lot of why we do testing. You know, it's really at heart to make sure your code does what you say it will. You know, I say this function takes a string and reverses it consistently. And testing is your proof.
Also,
you know,
there's this global variable that I didn't tell you about, like that can mess up something else.
Right, right. Yep. These are my notes. Yeah, to catch errors as we code is another reason. So test-driven development, Bonnie talked about that a week or two ago. You know, you write tests in advance, and then you see if your code satisfies it. And if your code doesn't satisfy it, you can be catching those errors as you go. This is an interesting one, to make sure we don't break things that we already fixed. So sometimes in code bases, if you fix an error, you'll write a test to ensure that that fix stays fixed. And then when you are doing things like, who knows what continuous integration is? Is that familiar to folks? Okay, I'll just say a bit about it. Continuous integration is a broader framework for doing testing on a regular basis. And so where you'll probably next encounter this is in P3 or P4. When you go to make it would be in P4. When you're working on a code base and you go to make a pull request to that code base, you made a change to some code and you want to submit it to the repo. Sometimes you will have a continuous integration system set up that automatically runs tests on your code anytime you want to make a pull request. And so it's this great way of catching at the time of deciding whether or not to add this code to the repo. Does this stuff still work? Did we break anything, right? Yeah, and then to test something that works in one environment and make sure it works in another. So, you know, something that works in on my machine, you know, popping it up in the browser. Does it work when it's served from a web server? Does it work when it's served from Heroku? Does it work when it's working with our production database versus our staging database? Those kinds of things. With me so far? So, yeah, so what kinds of things do we need to test? That's kind of the second question with all of this. Frameworks and libraries. Say a little bit more about that.
So far we used Mobile framework
Uh-huh.
and Child library for unit tests.
Mm-hmm.
I guess we can still use them for the integration tests.
Mm-hmm.
Yeah, that's you know about what we need to do. Of course, we can do manually, just come up with different use cases and pass them to our functions.
Mm-hmm. So you're saying we can use testing frameworks? Yep. Great.
Are you talking about like what do we need to test in the code, or like what do we need to test?
Ah, great. So what do we need to test in the code? What kinds of things in our code do we want to be testing?
Input validation, return values.
Okay. So input, validation, return values. What was the last one you said? Okay. You can see how this all is a reflection of, does my code do what I say it will do? You know, does it return what I say it will return? Does it handle exceptions in the way that I say it will handle exceptions? What else?
Edge cases.
Edge cases, okay. Yep.
Also, there is a thing called like negative testing. So when you provide kind of close to input validation, so when you intentionally provide wrong inputs,
Mm-hmm.
see how it's kind of goes to exception handling.
Mm-hmm. Invalid inputs versus valid inputs. Yep. Yeah, and so zooming out from this a little bit, there are, I don't know, everyone talks about testing in a little bit different way. You'll hear some people talk about integration tests and some people talk about acceptance tests. You'll hear some people talk about system tests and some people talk about end-to-end tests. And what's important in all of that is to just understand what you're testing and why you're testing it. That's really the heart of it. And you'll be able to work with other people who might have a little bit different language for, you know, what kind of a test is this? We should do this kind of testing. You'll be able to work with them because you understand what you're testing, what the purpose is. And so there are kind of two big things that when we zoom out are the things that we want to test. And so one is units. So this is unit testing. And what do we mean by this? Unit is an isolated kind of individual discrete unit of code. Oftentimes this would be like a function. Like a function is a pretty discrete, pretty clear unit. It doesn't need to be just a function. So, you know, there's a way of looking at unit testing where you could test a function, or you could test an entire module with multiple functions, and it's still a unit test because you're still testing, does this thing in isolation do what I say it will do what we want it to do. Another kind is integration. So this is, integration tests are really about two things talking to each other. Do these two pieces of code communicate with each other? So we could test this piece of code, we could test that piece of code, and we could know that they work, but do they work together? When I tell this one to send something to that one and display it on the screen, does it work? Is that clear, the distinction between these two? Questions so far? I guess I don't know exactly how to distinguish it from integration testing. That's one of those things where I haven't used that. I haven't used that language very much for it. So, let's see.
I was gonna say, isn't integration testing, doesn't that include unit testing within itself? So isn't like integration testing several unit testings?
Say more.
Okay, is a integration test combination of unit tests?
If I understand you, I don't think so. And that's the distinction I'm trying to make is, and again, there aren't exactly like hard and fast lines on this. So, you know, you could call one thing an integration test and someone else could call it a different thing. But the important thing to understand here at the root of it is, am I testing a unit in isolation to see if it does what it says it will do? Or am I testing, do these things that I'm assuming work, do they work together? Do they communicate together, right? And so the kind of test is different. It's a different kind of test that you're doing.
So we have end-to-end testing on there. Is that different than integration?
So, yeah, and again, this is one that I'm not speaking definitively here, but my experience of end-to-end testing is it's kind of system level integration testing. Like, you know, from start to finish, does something work? Does it do what it says it will do? So, what varies between the different test types? I sketched out some notes here. How many things are tested? So in a unit test, you're really aiming to test one thing, one unit, because you're wanting to ensure that that unit works, and separately you'll test, does that unit work with something else? How zoomed in and zoomed out are these tests? So are we testing like the whole system? Are we testing one little piece? And then kind of similar to that, are we testing a thing, or are we testing communication between the things? That's, again, that distinction between unit and integration. Are we using real resources, like real databases, real web servers, real command lines, or are we using stubs or mocks, where instead of a database, we plug in something else that's predictable, that we know will always do what we want. you know, there's this question: what are we isolating and what are we not? So unit tests often are isolating everything. You want to isolate that function. Integration tests, not necessarily. You know, system tests, no. You're wanting to not isolate things, right? And then, you know, I just thought of this kind of at the end. Are we testing this thing ad hoc, or are we building a test or test suite? So a lot of times when you're writing code, you'll be doing tests, and you may not even think of it as doing tests, but, you know, you'll write a little bit of code, you know, just the first couple lines of it, and then you go and run it in the command line, and you say, does this do what I think it'll do? Does it display hello world? Does it print, you know, these two numbers added to, you know, 2 + 2 = 4? So oftentimes in development, you'll do some kind of ad hoc tests, but then there's also this question of what kind of test suite are we building? And, you know, in here, we try to get you building tests pretty often for many of the benchmarks. And especially as you get more into P3, there'll be, you know, write this thing that accesses the database and then write a few tests. So good so far? Is this helpful? I wanted to look at this from the kind of like what's behind all of this. What's behind the names unit testing and integration testing, so that you understand we're unit testing and integration testing and smoke testing and whatever, you know, all of these things exist to test the kind of underlying things that we're talking about. Does the unit work? Do they communicate? Smoke test, incidentally, I hadn't really heard that before, and I was reading up on it, and apparently it's the test that you run to see if the thing starts smoking. So it's like if you had a piece of hardware and you were like, okay, let's run the smoke test. It's like plugging it in, and does it start, you know, smoking and shooting sparks everywhere, or does it kind of turn on? So it's just different names to describe what level you're testing, how many things you're testing. Cool. So yeah, these. So we were asking about what are unit tests versus what are integration tests. So this is just a definition that I have. Unit testing, you're testing a discrete unit or module of code to ensure that it does what it says it should. No dependencies on code outside of the unit, and any dependencies on things outside, you know, if it's reading a file or something like that, you want to stub that or mock that. Instead of reading the file, you want to just give it a string or something like that. Yeah, unit tests are, they test logic, the code logic, and they show that your code is correct. So again, does it do what we called, you know, what we say this function does? Integration testing, test to make sure two or more units are working together, two classes, or testing things in a production environment. Yeah, you imagine if you wrote a game, and so there's a game loop, and then there's the display module. It's like, does the display module, can it read from the game loop or the game state where the thing is supposed to be? Can this do something with that? Is this helpful? What questions do you have?
Do you have like code of integration systems? That's not like I'm getting a very picture see, but I would love to see it visually.
Yeah, I pulled up some code. So this is the command line to do. It's a command line to do solution, and yeah. So this is command line to do with callbacks. This I think was well, I thought it was written by Tanner, but it looks like Patrick may have written it. And so I wanted to have us look at the test file for this and see if we can pick out what these kinds of tests are, and if we would want to add some tests, what that would look like. So command line to do with callbacks, my understanding of this is you have a command line interface. You can call that to add a to-do, to mark a to-do as done. Is this right? Yeah. So pretty straightforward, and I think it writes to a file, this tasks.json file. So if we look at the tests that are here, and again, I don't know who wrote these, if it was Patrick or Tanner or somebody else. So we've got chai, and then we're bringing in our different functions. And we've got a data store, which is, this is, I guess, a file name for the data store. So, bless you. So what's going on in this first block here? So we've got a describe, and then what's this testing? Exactly, yep. Seeing if the run variable is actually a function. Why would you want to test this? Yeah. Mm-hmm. Can you imagine a scenario in which, you wrote a run function, but this test would fail?
You don't export it correctly.
Yeah, great example. The thing that I do all the time is forget to export the thing. So yeah, if you had a great function, it looks beautiful, you code it as great, but then you're not exporting it, this would be the test that would catch that. So we've got the same thing here with get to dos, with list, with add, and with done. And incidentally, these are well, I was going to say these are tests you could write in advance, thinking of test-driven development, but these don't really test all that much. They just test if the thing is a function. And so test-driven development is really more focused on the functionality of the thing. So
if you were to run this test, it would just say exists with a green check mark, right? It wouldn't actually say write your test state.
Yeah.
Say like run exists.
Yeah, so these tests, the labeling of these tests doesn't make a lot of sense. How would you relabel this?
Well, I think.
Say it again, James.
Oh, I was just saying, so that there's just one describe for the first function, but there really should be a describe for every function in there.
Mm-hmm.
Because it's just the it really only belongs to that first describe, and all the other ones are different functions.
Okay.
I think you could say describe. You could be like, you could describe that you were checking that these functions exist, and then each it could be like run exists, so that you know that when you doesn't Patrick to know which function you are testing. Versus like, yep, there's a function that doesn't exist somewhere out there, and you have to then check to see which one.
Say that again.
Just fix the labels. I would just add function name. And
To the
then
front, yeah,
function
run
exists
exists.
already there.
Right.
So like run function exists, get to do's function exists.
Yeah.
Like this? Make sense why we're making that change? And what you were saying, James, I'm generally a fan of that, doing more describes. So not doing a ton of its within one describe, but you're oftentimes describing a different thing that you're testing. So yeah, it's so subjective. I mean, in this case, we're really, describe, we're really just saying, do our functions exist? And so I think it's fine to be doing this. But if we were testing that they exist and that they return a value that we think they would, I might put that in a different describe,
I also like using context within describes.
Say more about that.
So just like describe, you can take context. It's an alias for describe. So you can have describe, and if you don't want it to have too many its, you can break it by having context within the describe.
Yeah, I haven't used that much. It's contexts,
No, just context.
and then you can say my command line functions, and then it takes a callback, right?
The way I've heard Jared describe context and the way that I've used it is like, it would be like when, for example, if you're testing something in SQL, you would have your describe your function, and the context would be when the database is empty, and then you'd have different contexts.
Got
when
it.
the database is full.
Perfect. Yeah, so you're describing the kind of test state. Yeah. Cool. So coming down here, what do we got here? Say it again, Miles.
So it looks like he's setting up a before what I guess would normally could go into a before function, but he's creating an array and then pushing some kind of test data into it, turning it into a string and writing it to a file for some reason. I'm assuming that reason is so that he can test and run and see that it gets this file and does a thing with it. It looks like run should take a command from bash and parse the data that he just saved into the data store file. And he wants to be sure that run puts out that data in comparison with the data he just pushed into the file.
I'm with you until that last part. This test, I guess I'm not sure, so I would want to look at the code. What is being tested here? It looks like run returns something. And so it doesn't seem to have to do with the file, right? But let's take a look at the code.
I was like, I don't know what's going on inside of run.
Right. Yeah, so run takes a command and a to-do, and list. So what is list?
It seems like run needs a read file somewhere. I think he's setting up the right file to have a test read file to read from. I just don't know what the code does as far as what it actually does.
Yeah. Let me say a couple things about this. I'm curious what you all see too about this. So, Miles, were you saying that this might go in a before each, or in a before?
I would think so. Again, not knowing how the code operates, I don't know exactly what they're testing yet. But if it's something, especially if it's something that's going to use over and over again, I would say before or before each.
Mm-hmm.
But I don't have that concept.
Make a function that returns that object fresh every time.
Say that again.
Like making a function inside the context so that before each test you make a clean state, like a clean picture of every test. Like you don't got something in memory or
Mm-hmm.
something like that.
Yeah. I think I would structure all of this pretty differently. And again, I'm not clear what's going on down here, but yeah. So an example of a unit test here would be if you did a before and you set some variable to be an object, and let's see. So you have the data, you've set what the data is, and then you tell the command line to do kind of main function to add something to it. Does it add something to it? And then an integration test would be actually creating a file, knowing what's in the file, and then doing the same thing, add a to-do to this, and then checking the file. Does the file have this new to-do that we just added?
Would it be written the same way that a unit test is written the same way as far as describe and try libraries?
Well, what would be different is in one, you would need to be stubbing the file. So you would need to write your code in such a way that you could either write to a file or write to like an object. So this is one of those things, the question of like how to write testable code. It's good if you can make your code configurable. That's the word that I would use for it, so that you can write to one thing, or you can configure it to write to another thing. And so with this, one way that you could write this code, this project, is you could write a function that is that doesn't care whether you're writing to a file or to an object, but maybe it just returns the to-do object, right? So you have one thing that just does the operation and a separate thing that writes that to a file. Does that make sense?
Yeah, like you can separate it in different files.
Mm-hmm. Yep. So
Does that kind of hinder the whole purpose of testing? Like if I'm setting up all these props to make the test happen, and then go, cool, the test worked now, and now I'm going to change all of the stuff to actually make this my production version. Aren't you then adding a bunch of stuff that you like didn't like? There seems like a lot of stuff that we say, all right, in this very special situation that I'm going to set up right before I run this test, it works. But when I send the code out into the world, there's going to be a whole bunch of not perfect. I'm expecting data to be just like this before I execute this thing.
mm-hmm.
So how do we actually test our application to make sure that it's not going, that in a world where it's not a perfect situation right before we execute this thing, that it doesn't give us some result? Like, is there a way to randomize the state before you go into something to be sure that it doesn't throw an error just because they clicked A before B instead of B before A?
Uh-huh.
Yeah.
What do you see about the answer to that?
It seems like that'd be very hard to set up, which is why I'm asking for somebody to show me how to do that.
Uh-huh.
And I seem to get a lot of
And what's the
theory
that?
around it and stuff. But
What's the that? Show you how to do that.
Like we've talked about, we could stub data. I've never seen that actually done.
Okay.
I've heard it about 4 times. That's a thing I could do.
Uh-huh.
So this is kind of what I was talking about, like with test pictures and stuff.
Yeah.
Like there's a library called Faker.js that will like it'll give you fake data like every time. Like you can pull like a bunch of fake data out of it. Like if you write a factory function,
Okay.
which is essentially something that like you can have it make new objects with that Faker library. So you can have it put out different objects, like different data in it. However you want to set it up so that whatever you're passing it into your test, you can randomize for that type of stuff.
Okay.
And like you can just have a function that builds those objects for you.
Okay. That's called
Faker.js.
Faker.js. Okay.
Fixture libraries. Just look at fixture libraries. There's a bunch of them. A lot of them do the same, but Faker is one that's really good.
Okay.
I know another thing that you can do if you happen to not do that is just write a bunch of tests. Like the more tests, the more different edge cases you're testing, the more coverage you're getting over these things. So what happens if we change this small thing? What if we concat, a string to an integer or something like that? And like at some companies, you have an entire QA department. Like those people are writing all like the hundreds and thousands of tests. So one way I like what Jonathan was saying. If you're not bringing another like module or tool into it, write all the tests for everything you can think of. And something's not great, and then you write a test for it. That's it.
Miles, there was something that you were saying that I thought was really important, which is if we just write all these tests that like show that one thing does a thing, we still have this problem of like, what about, I don't know if this is exactly how you said it, but what about when they, are put together?
Right.
And so that's really the distinction. Like just writing a bunch of unit tests is going to leave some pretty big gaps in your code, or in your code coverage in your testing. And so that's why we do integration tests. I don't want to try to contrive some like scenario to actually write out some code right now, but here's what I'll do. Before the end of the day, I'll post something to Phase 2 Slack that is some actual code where we're talking about stubbing and mocking and things like that. Yeah, we'll do that. Bye, Bob.
Yeah, I also think that like talking about how can we make sure that we're testing for everything. So depending on the type of our application, testing could be done. Like you don't have to write your test right in the beginning. Maybe if you need to gather some data before you can add more tests, maybe. So yeah, if there's like, I like what Monica said about like testing for all possible edge cases and doing your best, but you can always gather more data in the future and test with those tests, improve your code over time.
Mm-hmm.
That would be like one approach, I guess, to make your tests really good.
So you're talking about writing tests over time versus writing them up front?
Yeah, like so you start with something, but when you gather data that your code is breaking in these situations, then you can integrate that, and you can, make sure that those cases are taken care of.
Mm-hmm.
If you have other instances where code breaks, then you're going to do your best. Like you're going to do whatever you can right now, but just in case if stuff breaks, you can always go back and add tests.
Mm-hmm. Sure.
Yeah, I was about to say, like, kind of struggle. I'm like, I want to do test-driven development, and part of the struggle I'm having with these projects is like, I don't know enough of how the project works until I get into it to even understand how the pieces connect. Until I have like a little bit of it set up, like with the SQL thing. Like I had to figure out how to make SQL work with JavaScript and like how to do that whole process before I could even think about like, all right, how do I set up like a test suite that fills a data test database and all that.
Mm-hmm.
So I think that's where I'm kind of struggling is like that whole, like, as we get into these bigger applications, like how do you build this whole suite whose whole purpose is just to run a test? You know?
Yeah, no, I totally get you. And one of the things that may be going on here is that test-driven development is a design process. So when you are writing these tests up front, you are helping to design how your application is going to function. And so you might write a test that says, for this command line to do thing, you might say, write a test that says, here's a function that takes an object that's our data store and it adds a to-do. And so you can write a test in advance that says, this thing is a function, this thing given this object and a to-do returns that object with the to-do in it. And so part of the reason it may not be clear and may feel like you're kind of feeling around in the dark is because in the process of writing those tests up front, you're making decisions about how do I write my code? Is this what are the units? That's one of those big questions. Testing async stuff. Whose question was this? Do you have something specific that you're wondering about?
I haven't implemented any of this. I just saw some people.
Yeah. Yeah. So, where is? Yeah. So if you were testing something asynchronously, I'll give you the overview, and then maybe you and I can dive in more offline. But testing something asynchronously, the thing that's different is that your code, and this sounds really dumb and obvious, but your code is not performing its function in a synchronous way where your test suite can just wait, and then, oh, great. So the code is finished running. Did it do the thing? When you're testing something asynchronous, you're really saying, okay, asynchronous thing, you go off and do your thing. You check for that website, you query the database, you whatever. But when we do asynchronous JavaScript, you can't then in the next line say, great, and I want the result to be whatever, because who knows when that code will be done? It won't be done right after the kind of logical, right after that previous line. So that's when we get into callbacks and promises. And the basic thing with testing asynchronous JavaScript or asynchronous functions is you need to tell the test suite when your code is done doing what it's doing. And that's what that done function is. And so done will get passed oftentimes as a callback to your code to be run when that asynchronous thing has finally completed. So it's the last line in your code. Did it, when the database comes back and it says, I got 5 rows, here's what they are, then you're calling that done function to tell Mocha, great, now look for a result with whatever it is that I'm passing to done. Does that make sense as a kind of...
Whatever you say your test is in actually try testing that you're running right inside the done callback?
No, it's like the callback is going, when the test is done, the callback has to go and get the test out.
Yeah, why don't we come back if this is still a question next office hours and you and I can chat offline. Great, so I'm gonna get back to the crew with some stuff on stubbing and mocking by the end of the day. Any other final questions?
I thought we were going to check out another library that was not in OpenShine.
Yeah, what are you wanting to know about them? Like what they are, what they do, or how they're different, or?
Yeah, I mean, from what I've gathered, like there's a lot of people that use test anything protocol, tap protocol, and to me, just looking at it, it kind of seems simpler than Mocha Chai. Like what I understand, this is behavior driven versus like test driven, which is like from my understanding, that's more of tap protocol. It's more you put in your function. What does your function expect? That's it. Pass or fail equal. There's not as many, not as much setup, and then like when you run the test, like it's a clean. You're just testing the file instead of like I think Mocha actually like modifies the global state or something like that. That's just like my reading that it's better for like just keep your tests like. I mean, it's the point of like I guess like a philosophy type thing, but like just to keep your testing state clean and not even integrated or not even interacting with your global environment at all.
Yeah, I think you may be mixing up testing frameworks with this question of test design, because what you're describing is really good design for tests, and especially unit tests. So this whole idea of like you have a function, you give it something, it returns it, like boom, that is descriptive of unit tests, right? And unit tests are nice and clean and easy to test like that. And you'll encounter other scenarios where just unit tests, just the sum of your unit tests isn't enough. All of which is separate from which testing framework do you use. So there's Mocha and Chai, and there's Jest, and there's Jasmine, and there's a bunch of these different frameworks. They're different frameworks to run a set of tests that you design, and those tests could be unit tests or integration tests in any of them, right?
So, I mean, from my understanding, I'm just getting like the sense, even like when you read online, that it's like, it's really like a big subjective thing. Like, it's up to like, it's basically up to your preference, right? I mean, because most people use Mocha Chai, but what I've read, like, I mean, just people have different styles of testing. So I guess I just wanted to see like another library other than that. I just wanted to see it done in another library because we see Mocha Chai a lot, and I kind of just wanted to.
Is Mocha Chai like an industry standard?
I wouldn't say Mocha Chai is an industry standard. In part, it's what the guild picked as like, this is what we want people to learn. And there are some good reasons for that, I think. I was not the one that made that decision, but no, not the industry standard, but also learning Mocha and Chai will give you a lot of what you need to learn other testing frameworks.
So I guess going off that, is there anything else like go into a job interview and they're like, hey, can you use Iceberg to do some testing? Like, I don't know what that is. Is there like, or are they?
I don't know of any job interview where you'll be asked to write tests in a specific test framework. What you will oftentimes or sometimes be tested on in a job interview is can you write a unit test for your code? You may be asked, can you write an integration test? But unit tests are kind of the more like, they want to make sure you know what that is, that you know how to write one, that it works, that sort of thing. And you may be asked to like describe the difference between a unit test and an integration test, right? So we're at time. Thanks, everybody. I like that. The very gentle applause. Snaps. We could do snaps.
We're sophisticated.
I know. It's so classy.